Welcome back to the shrine. As you might guess from the cover picture, we got a new project on hand, and in this episode we're going to be lacing a wheel. This is a special wheel. I have a special place in my heart for Cannondale Lefty, and this is the Lefty hub. I was trying to get the new Cannondale scalpel bike, and for 6 months of research through Pink Bike and Craigslist, eBay, Marketplace, I couldn't find one that would fit my needs. So I decided to buy a stock bike and then equip it with the Lefty fork. So here's a picture of the stock bike. As you can see, it's got the double crown fork, which is the traditional fork. I'm a Cannondale connoisseur, and as such, I always liked the Lefty forks. I found this fork together with the hub and the spokes. So this gentleman sold me this as a set. So all I had to do is figure out what kind of rim I want to lace it into. And first I chosen a carbon rim, but they are pretty pricey. So long story short, I ended up settling on a DT Swiss XR 391. This rim measures 29 millimeters on the outside and 25 millimeters on the inside. This is a little wider than what I typically use on a cross-country bike, but this is just a new style that everybody uses. The DT Swiss rim came with the spokes and the steel washers. So these are special washers that you need to include with the spokes. Obviously everything is gonna increase the weight of the rim, but this is just something I'll have to live with for the time being. These are aluminum spokes. The head uses E5 Torx. The first problem with the Lefty is to remove this cap. So I need to remove this cap in order to mount this in a throwing stand. I have a traditional throwing stand which has two standoffs, and so you can see that from this side the Lefty is closed shut. A couple of years ago I made this tool. It's a simple tool. I just drilled these holes and I populated these spokes. I just cut pieces of spokes that would engage this nut, and it worked kinda okay. But what happened is when I used it, it had a tendency to hurt these openings and smash them. Since I have a CNC machine, I designed a new tool, went ahead and cut these two pieces. They designed to engage with a 3/8 tool like this. They are made of aluminum, so essentially it's the same hardness, and I can use it to conveniently remove the nut. Disclaimer here, the nut has a left-sided thread. Righty-loosey, lefty-tighty. When I created this tool I was so happy. I put this on my Instagram, and then someone pitched in, "Oh, why didn't you use the cassette tool?" I had this toolbox for 20 years. This is the tool he was talking about. This tool is used to remove cassettes. If you look, it will be perfectly good to engage the Lefty cap. Okay, so don't do the same mistake what I did. Don't make a tool. Don't buy a tool. Just use a normal cassette tool. This is a tool that is designed to remove cassettes. A little tangent here. If you ever hear a squeaky noise from your front wheel and you don't know what that is, and you suspect that it's a seal or a bearing, it might be this O-ring here. This is the bolt that mounts the Lefty to the fork. And as you can see, it's got an O-ring here, and that O-ring is riding in this cap. So what happens is this O-ring will essentially deteriorate, and when it does so, it will start cracking, and then you will hear this squeaky sound. If this squeaky sound is coming from your Lefty hub, you might want to disassemble it and replace this O-ring. So now I have a tool. I was able to remove the cap. The next problem is how I'm gonna mount this in the truing stand. So I went ahead, machined an axle. Here's the axle. I had to add a little spacer here, but it goes in, and with that I'll be able to put this into my truing stand. Lacing the wheel is not a rocket surgery. I'm not going to go into details. You know, if you're lacing any kind of wheel, you can just go online, find some pictures like this, and basically figure out which spoke goes in which direction, and then which spoke is outside, which spoke is on the inside, how many times the spokes are crossing each other. So I went ahead and printed these pictures so I can figure out how it's laced. This is a 28 spoke pattern, so the rim I had to purchase has to have the same amount of holes. So it's not 32, not 36, it's 28. The next problem was that these spokes are not bladed. So not bladed means that they completely smooth and cylindrical. These are double butted spokes. The butts refer to the end of the spoke where the spoke is thicker. Why is it thicker at the ends? Because that's where the stress is, that's where the features are that engage either the nipple or the hub. So if you take a look here, the center of the spoke measures at 183, and then the ends measure at 2 mm one end, and it's 2 mm on the other end. That's why these are called double butted spokes. So the next problem is, when I insert the spoke here, there is nothing really that would hold the spoke from rotating. So I went ahead and I bought a Park Tool CSH1, which is designed to hold these spokes while you're applying the torque to the end. So you can see when I squeeze the tool, it is gonna hold the spoke so the spoke will not rotate. So that's done. These pull-through style spokes are really hard to screw up. There's only one way that the spokes want to go. Next thing is lay the wheel down and basically just attach the nipples with the washers. Now I'm just gonna do a dry fit first, and then once everything lines up, I'm gonna take the nipples off and I'm gonna add thread locker to the end of every spoke. If you look at the spokes, you can see the red patch here. That is thread locker, and that is added to prevent the spokes and the nipples from loosening. I'm gonna use blue thread locker instead of red. This is after I lightly tighten the nipples on the spokes. What I essentially did is I drove the nipples in until the end of the thread. So the next thing is double check, triple check everything. and then I can take every spoke out, put some thread locker on it, and go for the final tightening. You'll end up with a lot of extra parts, don't worry. These kits are designed for 32 spoke wheels, and they still include a couple. Just save these because you're gonna need them if you're gonna use the wheel for a while, because these spokes will break over time. You can certainly accuse me of overdoing it, but you cannot accuse me of half-assing it. What we got here is about 98 kilograms of weight, someone can call it mass, hanging on the very spoke that is built into the wheel. The manufacturer of the spoke recommends 120 kilogram force of tension. This device, my friend, is a spoke tension meter. The original is made by DT Swiss, and I knocked it off about 10 years ago. Essentially, I just made a copy for myself. The way it works is you first have to calibrate the dial to the weight, and what it essentially does, it's a 3-point bending device. So you can see there's 1, 2, and 3 points. So when I put a piece of wire across these pins and I let it go, the spring is going to provide a certain amount of tension, and then the dial is going to register the movement of the steady and the moving arms relative to each other. When you have tension in that said wire, the displacement is going to be less. So I can put the tension meter across here, and I can see what the dial says, and you can see it's 45. Now, as far as repeatability, it's not the world's greatest instrument. So right now it shows 40. Let's do a third measurement right in the center, and you can see it's 41. You can see it always goes back to 0. That's important. So now I have 98 kilos hanging on this wire. I can remove the weights one by one and see what kind of measurement the tension meter is going to show. That way I can calibrate this spoke tension meter to a given weight, and I can build a chart. Why spoke tension is that important? Let me introduce you Exhibit A. This is a Mavic rim, and as you can see, it didn't fare well. These cracks that you can see here are from fatigue. What happened is, due to the high spoke tension, this gland here on the rim just fatigued out. You can see the fatigue cracks are initiating from the threaded surface. This is Exhibit B, which is a No Tubes ZTR Crest 29er rim. Same thing happened. As you can see, the rim here completely fatigued due to the improper spoke tension. This is Exhibit C. This is a Crank Brothers Cobalt twin par spokes rim. As you can see, it didn't fare well. This area here is fatigued. Upon closer examination, you can see the beach marks on this surface. The beach marks are a telltale sign of fatigue. Again, what happened here is probably due to the high spoke tension or uneven spoke tension. This one is fatigued out. That's why I'm putting so much emphasis on measuring the spoke tension in the spokes and make sure that they evenly tensioned. I did check the spoke tension on my brand new Cannondale Scalpel wheels, which are Stan's Crest 32 spoke. And I also did check on this carbon wheel. This is a Giant SLR1, and the results are interesting. The Cannondale wheel, the two sides are not equal, so you got the disc side and then you have the drive side. So one side has an average 71 reading, the other one is 37. Again, 67 and 41. So that results to about 120 kilos of force on one side and about 90 kilos on the other side. So the range is, you can see, pretty large, 30, 38, 59, 48. That is the reading on the spoke tension meter. However, if I look at the Giant, which has, you know, carbon rim, you can clearly see that this was designed in a wind tunnel and it was put together by intelligent robots. Because if you look at the range, it's 7 and 8. So that means that this Giant carbon wheel, this was fine-tuned, so that these spokes on both sides are pretty close tuned to each other. But again, on the Giant wheel, you can see that one side has about 102 kilograms of force and the other side has 32. So the wheel is not balanced side to side in either case. These are my charts based on my measurement. So I applied different load to the spoke and then I figured the dial reading, and then from that I can back calculate if I want to apply 120 kilos of force, my dial reading should be about 67. Again, at this stage the spoke placement is verified, the crossing is verified. So what I'm gonna do is remove each nipple one by one, add thread locker to the spokes, and then go to the tightening sequence. So we are at the point when all the spokes have thread locker on it, they lightly tightened. You can see the wheel has a little bit of hop. The hop is the radial run out, and then the through is the axial run out. It's just the bike jargon. Overall it looks good. So at this point I'm gonna go and tighten each spoke for 1/2 of the revolution, and then I'm gonna go with my tool and verify the spoke tension in each of the spokes. Right now you can see the spoke tension is basically 0. After half a turn on each of the spokes, you can see we got some tension. So there's 22, here's 20, here's 20. So you can see it's pretty uniform. So that's where a tool like this becomes really handy, because you can verify your work. When you are tightening these spokes and just doing, you know, 1/2 a turn at a time, it might seem that some of them go easy. You know, they're not tight enough, and you have a tendency just to go 1/2 a more turn. But that might be just because you have some oil on that particular one, and so the coefficient of friction is less, so it seems easy. These were tightening 1.5 turns now, so that one is at 60, this one is at 50, 46, 60. So you can see it's not even. This is the point when I'm gonna go and look for run out, see how much run out I have, and basically do the hop and through together with tightening the spokes. So this is the final stage of the through process, and this is the most critical one. At the end of the day, what I want is all the spokes to be equally tensioned, and I also want the wheel to have the minimum amount of hop and through. I think this is pretty much the point where I need to stop. I'm not sure if the footage will show this, but there's about a millimeter clearance right here between the caliper and the wheel, and you can see the gap as the wheel rotates is pretty consistent. I really don't have good ways of showing that gap, but that is the idea, that that gap is constant. I've looked into new wheels, and typically the runout is about 1 millimeter, both the axial runout and the radial runout, or hop and through. As far as the spoke tension go, it's fairly consistent. So here's 157, 52, 60, 54. So it's plus minus 5. So again, a reading of 67 would indicate 120 kilogram force. So I'm between 100 and 120 kilos of tension on these spokes. It's essentially the same on the drive side. So this is the brake side, and then the far end is the drive side. Since I'm at it, I'm just gonna go and replace these bearings. These are the standard bearings that came with the wheel, and I got new ceramic bearings. These are not true ceramic, but what they call hybrid. So it's got ceramic rolling elements with stainless steel races. We got the brake side, which is 6805. It's 25 ID, 37 OD, and 7 millimeters wide. And then we have the drive side, which is 6902. It's 15 millimeters ID, 28 OD, and 7 millimeters wide. Acer Racing, they carry all your bearings. I'm not affiliated with them. Hope you guys enjoyed the video. This will be a wrap. Please leave a comment, and if you're not subscribed, please do so. See you on the next one. Bye.